Hello there, ROS developers, and welcome to this live class number 122, where we are going to be doing the ROS manipulation on a real robotic arm, part 2. So, let's go! Alright, so hello everybody and welcome all of the ROS developers that today are here with me. So as I have just said, today we are going to be doing the part 2 of the robot manipulation with a real robot live class that we did a couple of weeks ago. We are going to go a little bit deeper today into the scripts, and we are going to analyze better the script and how it works. The script, the Python script that we are going to use today in order to control and move the robotic arm. So yeah, welcome everybody. Hope all of you are good, and let's go for it. So let's not lose any more time and let's go straight to it. Let me say hello to Engineering Nations, Lucas, Sergey, Thomas. Hello everybody. Microphone is a little bit quiet. Okay, let me try to fix this. Hello, hello, hello. Let me try to. Hello, hello, hello. Hello, hello, hello. Hello, hello. Hello, hello. Okay. Let's leave it like this. All right. So, yeah, let's go for it. As always, we are going to be working in the construct. So let me quickly switch. Let me quickly switch to my computer screen. And we are going to log in inside, and remember that we are no longer working with links, so I'm not going to share any link in the chat or anything similar, okay? The process now is to come to the main page of the construct, log in with your account. In case you don't have an account, just create it. It's completely free and it's going to take just a few seconds. Go for it. Then once you are logged in, all you have to do is to come here to the left menu and click on the Live Classes section. I'm going to do this right now, Live Classes section, and here click on the Live Classes. You are going to see the current streaming, the current live class that I am doing right now, and here in the upper right corner we have a very visible button here in a light electric blue color, which says fork and open the class rosject. So you have to click on this button in order to get and copy into your account the rosject for today's live class. So I'm going to do it right now. I'm going to click here in the fork and open the class rosject. This is going to automatically copy and open the rosject here in your application. So all of you, let's do it. Let's do it all together. Let me mute this. There we go. And here we are going to have, you are going to have everything that you need in order to follow the live class. So you are going to have here the live streaming in order to hear what I am saying. You can also visualize and see what I am doing. You also have access to the chat, which I am going to open right now. Let me open it here. Visualize and see what I am doing. Oops. I still have this blocked. I'm hearing myself double right now. Sorry for that. I'm going to mute myself as soon as I can. I'm hearing myself double right now. Sorry for that. I'm going to mute myself as soon as I can. Okay, so here, as you can see, the rosject files are being loaded. Let's be patient. In a few minutes maximum should be loaded. Mine is actually already loaded. So you are going to also have automatically open the the notebook, the Jupyter notebook for today's live class. All right, here I can see all you say. Microphone is a little bit quiet. All good, says Engineering Nations. Okay, so I hope the sound now is good and you can hear me clear. And yeah, so all of you at this point should have this same scenario that I am seeing right now. So you should have your rosject for the live class. Open it. Here, the notebook where we are going to be following all the instructions and everything that we are going to be doing today. And also here you have access to the live streaming with the video stream and also to the chat in case you want to place questions or anything. Is this Mr. is asking, is this about ROS or ROS2? This is about ROS1. Okay, this live class is based in ROS1, this rosject. You can see here that it's based in ROS Noetic. So this live class is based in ROS1. Is this going to be, is that knowledge applicable to ROS2? Well, some parts are applicable and some others don't. So ROS2, there are many things that are different from ROS1, but also there are others that the idea is the same. So yes and no, I would say. So probably the program that you would have to create in ROS2, the code is going to be different from ROS1. However, the background idea is going to be more or less the same. Already, says Santosh. Okay, let me know here in the chat, please, if you are set up also. You're welcome, Mr. I don't know if I should call you Mr. or MR. I don't know. Hi, where can I find the rosject? Okay, let's show it again. In the main deconstruct screen here, in the main deconstruct screen, you come to the left menu and select the live classes option. All right? Live classes. You come to the live classes and you are going to see the current live class here. As you can see, ROS manipulation on a real robot arm, part 2, which is currently being streamed live. I'm doing it right now. All right, then here you are going to see this light blue button, fork and open the class rosject. You should click on this button in order to get today's rosject. All right, super easy, straightforward. So go for it. And all of you, the new ones who have arrived a little bit late, click here and you are going to get the rosject for today's live class. Ready, says Thomas, ready. My notebook didn't open automatically, says Ricardo. I'm sorry to hear that, Ricardo. Ready, says Pia Saha also. Okay, excellent. Then a couple of things. So before starting, let me remind you one thing, because otherwise my colleagues are going to kill me. So I want to remind you, first of all, let me grab the link here. So first of all, I want to remind all of you about the ROS Developers Day that we are going to have this year in June. Is going to be the 4th edition already, 4th ROS Developers Day, which is basically a virtual conference, which is going to be based in the same method as live classes work. So we are going to be providing different rosjects in order to teach different ROS concepts, ROS or robotics concepts. But the idea behind is going to be the same as live classes. So we want you to practice, to learn by practicing. So these are not going to be just conference where the speakers are going to be talking or showing images, showing slides, etc. No. It's going to be a practical conference. So for every speaker and for every conference on this ROS Developers Day, you are going to have your rosject where you are going to learn by practicing. All right? Then it's going to be super interesting. You can see a recap here in the page. The ROS Developers Day 2021. Let me actually share it with you here in the chat. so that you can check it. All right, super interesting. We already have some confirmed speakers, also some confirmed sponsors. You can check here all the information that you want. And the thing I want to remind is that, let me get the data here because I don't remind it right now. So tomorrow, April 28th, is the deadline for the early bird ticket registration. Okay, so very important. Tomorrow is the deadline for the early bird ticket registration. And also I want to remind you, in case you would like to apply for being a speaker in this conference, the deadline is going to be May 3rd. May the 3rd. All right, so May the 3rd is the deadline for applying for a speaker, and tomorrow, April 28th, is the deadline for the early bird ticket registration. All right, so this is the first thing I wanted to remind you. I have already shared the link with you here in the chat, so have a look. And the other thing is just, I want to remind you a little bit the planning for today's live class very quickly so that you have an idea of what we are going to be doing today. So first of all, we are going to start by working on a simulated version of the robot, of the Manipulator robot, which is this one here. And this is a gazebo simulation, of course. This gazebo simulation is a representation, a very accurate, let's say, representation of the real environment. All right, then we are going to be first working on the gazebo simulation, and we are going to be launching MoveIt. We are going to also execute a Python script in order to control the arm. And once we have tested all of this in this simulated environment, then we are going to connect to the real robot that we have here in our lab. So we are going to connect to the real arm, as you can see here, and we are going to execute the same Python script that we executed in the simulation. We are going to run it in the real robot, and we are going to see if it works or if it doesn't. All right, so this is the planning for today. Then let me get a quick drink here. And let's go for it. So first of all, let's come to the beginning here, to the top of the notebook. So the first thing, of course, many thanks to the Clarkson University, and especially thanks to James Carroll, which they have provided to us this open manipulator robot, the one that we are going to be using today in this live class and the one that we have here in our real robot lab. So many thanks to the guys of the Clarkson University and to James Carroll. And now let's first start, as I have just said, by launching the simulation. So in order to do so, we have the instruction here. It's super simple. How to launch the simulation. You can come directly here, and the first thing we are going to do is to open a shell. Of course, we are going to need to execute a command, so we need to open a new web shell. We can do this by clicking here in the web shell icon, which is the first one here from the bottom bar. The first one, web shell. If we click it, this is going to open a new shell for us. So here we can execute any commands. In this case, here we have the exact command that we need to execute in order to start the simulation. So you can, in fact, I suggest to copy it directly here from the notebook. You can select it and copy it, for instance, by pressing Ctrl+C. You can copy it here and paste it directly here in the web shell with Ctrl+V. So this way you are going to be much faster than if you have to type it and so on. So let's copy here the command from the notebook, paste it to our web shell, and execute it by pressing the enter button. So now this is going to start launching all the things required for the gazebo simulation. And once it is launched, now we have to visualize the simulation, because at this point we are not able yet to visualize the simulation. So in order to visualize the simulation, we need to start the gazebo client. And how can we do so? By clicking on this icon here, which is a cube. It looks like a cube here. This icon that we have here, you can click on this icon and this is going to open the client, which is going to allow you to visualize the simulation. Here we have it. All right, so here we have the simulation for our robotic arm. You can see it here in the center with this environment. You're going to see in a moment when we visualize the real environment and the real robot that the simulation and the real environment are very, very similar. Okay, this is an important thing when working with real robots, is to always, we like to recommend to start working with simulations, all right? Before working directly with a real robot, it's always much better to test in a simulated environment because it's going to allow you to detect errors. You are going to save time later. Also, it's much more safe because you are not going to break your robot because of stupid mistakes. So you can test in a simulated environment without any fear of breaking the robot or whatever. And this way you can detect possible errors that would be fatal in the real robot. All right, so always recommended to start working in a simulated environment before moving to the real robot. And for doing this, it's always important to try to have a simulation which is as accurate as possible and as similar as possible to the real world. All right, always it's going to be impossible to have an exact representation of the real world or the real robot. Is always going to be impossible because in the real world there are too many variables, but you should try to do it as accurate as possible. I can see some comments here. Let me have a look. Okay, I see that already Engineering Nations and Ricardo are answering Luciano. Great. All right, so have you launched the simulation? Yeah, do you have the gazebo simulation running? Can you see it here as I am seeing it? Yeah, let me know here in the chat if you are at the same point as I am. PL Saha says yes, working. Okay, great. Then let's go for it. So let's keep going and scrolling down here in the notebook. So here I have left here in the notebook some instructions. We are not going to do them in this live class. I'm not going to do this right now, but I have left them here so that you can check them afterwards and test them and whatever. Okay, so here you have a command and an explanation of how you can control the robot arm and the different joints of the robot using this very nice RQT joint trajectory controller GUI. Yeah, in fact I showed this in the last live class. So in case you want to see how to do it, you can check live class number 121. Okay, you are going to see how I do this. So I'm going to escape this part. You can check it and try to reproduce it later, however, when this live class finishes. So it's up to you. Also here you have a section in how to run a MoveArm demo. This is a script that basically is going to start moving the robot to different random positions. Okay, I'm going to skip also this part. And I'm going to jump directly to the MoveIt section, okay? So I'm going to start by launching MoveIt. So in order to start MoveIt, we have also the command here, okay? So what I'm going to do is exactly the same as I did before. I'm going to directly copy the command here from the notebook, and I'm going to paste it here. So in this case, I have this shell occupied now. So what I'm going to do is to open a new shell. I can click here in the plus button, in the plus icon that I have here. And this is going to open a new shell. Then now in this new shell, an empty shell, I can paste my command and run it. Okay, so this is going to launch MoveIt. And what is MoveIt? Well, MoveIt basically it's the tool. It's the tool, let's say, the tool in capital letters for ROS manipulation. So if you want to work with robotic arms and to work with motion planning, etc., MoveIt is the tool. It's going to make your life much more easier. So I'm not going to explain neither here how to create a MoveIt package from zero. We have some courses. In fact, you can check here in our academy in the courses section. We have here a category which is manipulation, and here you are going to find, for instance, the ROS manipulation in 5 days noetic course, which is going to explain you how to create a MoveIt package from zero. Okay, so in case you are interested in knowing more about this, you can have a look at this course where you are going to find step by step how to create a MoveIt package from zero. All right, and many other things related to this live class. Also, you can check them here in this ROS manipulation in 5 days course. All right, then let's come back here. Yeah, my real Robot Lab session has finished. All right. Okay, so now I have executed my command here. So now my MoveIt has been launched. So now, in order to be able to visualize MoveIt, you have to click in this computer-like button. Okay, you have also all these instructions that I am explaining right now. You have them here in the notebook also. In case you prefer to read here from the notebook than listening to me, you can do it also because you have everything explained here in the notebook. So, in order to visualize MoveIt, the MoveIt application, we have to click on this computer-like icon, which is going to open the graphical tools. Let me click it right now. And here we are going to be able to visualize the MoveIt application. Let me make it, maximize it here for a moment. Now, as you can see here, the window is like cropped here at the bottom. So in order to fix this, you can, for instance, double click here in the top bar, in this top blue bar. You can double click here and this is going to maximize and readjust the interface here to the window size. Working, still loading. What is it still loading? Engineering Nations? The rosject or the simulation or... Guys, you are doing a great job. You are killing it. Thank you very much, Goku. Thank you very much. We really appreciate your comment. No class here, says Dark Crew. What do you mean? No class? It says preparing rosject files. Okay, that's strange because it's not possible that it takes so much time. I mean, it's not possible. Then I would suggest, I don't know, try to go back and go to the My Rosject section and try to run it from there. Could you try that, Nations? Probably you have already forked the rosject to your workspace. So if you go to My Rosject section, you should see the rosject there. Maybe you can try to click on the run button from there and see if that way it starts. Can you also take a session on moving arm to an object using DeathCam? It will be so helpful. Yes, Gokul. In fact, this is one of the live classes that we are planning to do in the close future. To get the position of an object from a depth cam, and then use this position to send it to MoveIt so that the end effector of the robot arm goes to that position. We are going to do for sure this live class in the near future. The current one does not appear in live class. What do you mean? The current one does not appear in live class. You have it here. It's this one. ROS manipulation on a real robot arm, part 2. It's this one here. The one that appears here in the top, the newest one, the one that appears here in the top, is this one. Okay, we'll try that, says Engineering Nations. Let's see, because as I was saying, it's not normal that it takes more than 20 minutes to load, so that's not possible. There must be some kind of error there. Okay, so let me keep going. So here I have the main MoveIt screen, all right? So here alone, I can already work and create motion plans and execute them with my manipulator just by using this GUI, all right, without worrying about anything else. Of course, in this case, you already have the MoveIt package created by us, so all that steps, you have escaped them, but in many cases, you are already going to find a MoveIt package created for the robot manipulators, all right? So let's see a little bit how to send a goal here to the robot manipulator. So there are different options. One of them, for instance, could be to directly move here. As you can see in the end effector of the robot, we have this circle here that you can select it and move it, as you can see. And you can set the end effector to whatever pose you want. For instance, let's put it here. Okay? So now, once I have set the end effector position to the position I want, I can click here in the plan button. As you can see here, in the commands section, you have this plan. So if I click in this plan button, what is going to happen is that MoveIt is going to calculate the motion plan between the current position, which is this one, as you can see here between this position, which is the robot here in a vertical position, going to calculate the motion plan in order to go from this initial position to the resulting position that I have set here. So let me click actually here in the plan button so that you can see it. And as you can see now here, I can visualize, let me try to zoom. I can visualize how the trajectory planet is. So MoveIt is not only calculating this motion for me, but I can also visualize how this trajectory is going to be. All right? Then once the motion has been planned, I can click on the execute button. For instance, let me do it real quick here. Let me, by the way, minimize. Let me minimize this. There you go. So now, what I'm going to do is to click on the execute button. So what is going to happen? So far I have clicked in the plan button. So I have only done the motion planning. Yeah, I have not yet executed this motion. I have only calculated what the motion would be, and I have also visualized how this motion is going to be. But I have not executed it yet. So in the simulation, the robot arm has not changed its position yet. So now, if I click on the execute button, this motion is going to be executed. Let me do it. And as you can see, the robot here starts to move in order to reach the goal position I have sent to it. the goal position for the end effector in this case. And there we go. It has reached the goal position. Okay. Another option that we can do here in MoveIt, for instance, let me put it here a bit bigger, is to select already some predefined poses. So here in the query section, we can come to the goal state, and here we can already select some predefined poses. For instance, the arm 0 pose is the vertical position. So I can come back here to this vertical position. There you go. So now I'm going back to the vertical position. Okay? These predefined poses that you can select here in the goal state are defined when you create the MoveIt package. Okay? I'm not going to show all of these right now because of time, but these poses, you can define them, and you can define as many predefined poses as you want when you create the MoveIt package. So, all right. So we have seen a little bit here how to deal and how to work with MoveIt. So let's right now move to the Python script. Then, okay. So move the robot arm with a Python script. Then here in the notebook, we can see an example Python script, a pretty simple example Python script to show how to control the robot from a Python script connecting to MoveIt. Yeah. So from this Python script, we are going to connect to MoveIt in order to control the robot. What does this mean? That if I run this Python program, this Python script alone, it's not going to work. Yeah, I need to have MoveIt launched, as I have here in this shell, in order to be able to run this Python script, because I am connecting with MoveIt, as you can see, using the MoveIt commander. And MoveIt commander is basically an API which allows me to send Python commands to MoveIt in order to control the arm. All right. So this is what we are going to be doing here. Then this is a pretty simple Python script. So let's review the most important parts here. So basically, there are 2 or 3 parts that we are going to be seeing here. Let me have a quick look at the chat here to see how you guys are doing. Thank you very much. I love to do it. I was ashamed to book another time. I can see Ricardo Tellez here is multitasking here and answering many questions at the same time. Let me see. The gazebo simulation with the manipulation is not visible. You mean this one? You have the instructions, Jayanta. You have the instructions here at the beginning of the notebook. Here in how to launch the simulation. Here you have the command. You have to run this command in order to launch this gazebo simulation. When we click execute, it does it for once, but it is also possible to go back to first position and continue the same again. When we click execute, it does it for once, but is it also possible to go back to first position and continue the same again? I don't quite understand. What do you mean, Pillan? Can you maybe rephrase the question? Okay. I want to get into location. Okay, let me book a day for. Okay, still loading, unfortunately, after reloading. Well, that's super strange, nations. Yeah. There must be something strange there. So maybe Ricardo can have a look there, because it's not normal that your rosject is not starting. That's not normal for sure. The ROS launch as well as MoveIt are running in the terminal. Okay, and then you have to in order to visualize the simulation, you have to click on this cube icon here. Okay? In order to visualize the simulation, you have to click on this cube icon here. And then you're going to visualize the simulation. Yeah. Did that already. Okay, then I don't know. And what do you see here, Jayanta? I mean, is it possible that the execution will work continuously until I plan any other motion? Well, the execution will work until it finishes the execution. I mean, if you check here the logs, you can see execution completed, succeeded. At this point, the execution finishes, so you can plan again and execute another motion. So here, if you check in the MoveIt logs, basically you can see step by step what is going on. So you can see here this parallel plan solve function is called. You can see solution found by one or more threads. So a plan has been found. Start planning with one state already in data structure. Execution request received. This, for instance, is when you click on the execute button. Then the execution order is sent to the controllers so that the links start moving, the joints start moving, and then the execution is completed, and at this point, execution ends. Okay, let me keep advancing because can I do 2 or 3 plans together? Yes, it's possible to create loops of plannings. Yeah, that's possible. That's possible, PL. Yeah, that's possible. Yeah. Yeah, of course, it's possible. Okay, so let me advance a little bit because otherwise I'm going to be without time. Okay, so let's come back here to the notebook. Let me come back here to the joint, to a Python script, and let's review here the most important parts. So first of all, we have to create a robot object. As you can see here, we have to instantiate this robot commander. Okay, which basically is going to act, this robot is going to act as an outer level interface to the robot. Okay, we have the robot element. So this robot variable, this robot commander, is going to be like an interface to communicate with the robot, with the manipulator arm in this case. We have the scene element as well, a scene interface, which is this planning a scene interface, which basically is an interface to the environment that is surrounding the manipulator. In this case, the environment is this environment that we can see here with this cube-like area with these small cubes inside. All this is the scene where our manipulator is. Okay, then we can interact and communicate with the scene through this planning a scene interface. Okay, then also super important, we have the group name. The group name is going to be the interface that we are going to have in order to send commands directly to the different joints that are defined in the planning group. Okay, so let me very quickly try to show this. This group is super important because it's the group that is going to allow us to do the motion planning. All right. So this group basically is a group of joints. Yeah, manipulator robot, as you know, as any robot, but this manipulator robot is divided in different links, which are connected between them with joints. Yeah. Then we can select some links to be inside a planning group and left other links outside a planning group. Then the links that are inside the planning group are the ones that I'm going to be able to plan for. All right? And these links that are part of the group are defined when I create the MoveIt package. All right? So let me show it very quickly so that you have a better idea of this. You don't need to do this if you don't want to, because this is not in the notebook. I'm going to just do it to try to show you and explain a little bit better this, okay? Because otherwise it's going to be a little bit abstract, maybe, if you don't have any ROS manipulation background. Okay. Oops, sorry. Okay, so basically what I am doing now is to load here in the MoveIt setup assistant. I'm loading my MoveIt package. This is going to allow me to visualize and to see the configuration. I can also modify the configuration here, of course. I'm not going to do it, however. Then, as you can see here, I have many different things to configure it and to set up. So one of them is the planning groups. We have it here in the left side, planning groups. This is one of the most important. And here, basically, I'm going to define the planning group. Yeah. So here, what I am defining are all the joints that I want to plan for. Yeah. So in order to create a specific trajectory for my robot arm, I'm going to control the joints that are specified in this planning group, which is named arm. Okay. And here I can edit this, of course. I can change, for instance, the kinematic solver I want to use for doing the motion planning. I can change which links I want to include into the motion planning. I can create other planning groups, etc., etc. Okay? But basically, as you can see, this is configured when we create the MoveIt package. Okay? So again, if you want to know more details about this, have a look at you can have a look at the manipulation course. ROS manipulation in 5 days. Okay, here you're going to find much more detailed information and what all these configurations are, how to configure all of this, and how to create a MoveIt package for any kind of manipulator robot, etc., etc. Okay, in this live class we don't have time, unfortunately, for covering everything. Okay, so let me already stop this. And I'm going to actually run again my MoveIt package. Then let me come back here to the notebook. Okay, so here what I'm doing is to define the group name. Then I am defining also other things like the planning frame, which is, in this case, is world. Well, actually here what I am doing is to get all this information. So I am getting information from the MoveIt package because it can happen that You don't know this information. So you can get this information and print it in your script for reference and for getting all this information. For instance, knowing which one of the links of the robot is the one of the end effector. I can also get the current state of the robot. For instance, which is the current position of the joints of the robot, which is the current pose of the end effector of the robot, etc., etc. Okay? So basically here what I am doing is setting up the different things that I need, which the most important ones are, first, the robot, which is the robot commander, second, the scene, which is the planning a scene interface, and finally the group. Okay? These are the three most important things to set up here. All right? So once you have set up this, you can already plan. You can create plans. Here, we are doing a plan. And as you can see, it's quite simple. So what I am doing here is to define this joint goal variable, and I am setting a different position for each one of the joints. Joint 0, joint 1, joint 2, joint 3, joint 4, joint 5. So for each of the joints that are defined in my planning group, which is ARM, this ARM planning group, for each of the joints, I am setting a position value. So for joint 0, I set 0. For joint 1, I am setting minus P force. Yeah? Etc., etc., etc. And by setting a different position for each one of the joints of my planning group, what I am doing is to create a goal. Yeah? Does this make sense? Do you understand this? How we are sending different, we are setting the position goal for each one of the joints defined in our planning group? Do you get this idea? Yes, 6 pillal, okay, great. Is this, let me make a question. Is this the only way you can send goals to MoveIt? By setting values for all the joints of the planning group? Is it possible to set a goal for our robotic arm in another way? Does somebody know the answer to this? There should be more ways, right? Yes, there are more ways, Alejo, yes. You are right. Another way, for instance, is instead of defining a position for each of the joints, I can set a pose for the end effector, for instance, which is the one we did in the first demo, remember? So here, we are forgetting about all the joints of the robot, which are, so for instance, joint 0 would be here, joint 1 is this one here, joint 2 is here, joint 3 is here, etc. So in the first example that we did, we forgot about all this and we set, what we defined was the position and orientation of our end effector, which is this one. So this is another way in which we can also plan and send a goal to MoveIt. We can define the position and orientation of the end effector, okay? In this case, we are setting values for the different joints, but there are also other possibilities, just that you know, okay? I'm not going to show it now, how to do that. It's also in the ROS manipulation course, explain it. But I just wanted to bring it here so that you know. Using inverse kinematics, yeah, exactly. set goal position and use inverse kinematic. Yeah, it's exactly. Okay, so okay, then once I have defined it. Yeah, by the way, once I have defined the positions of the different joints of my group, I can call the plan function. See? So what I am doing here is to set the goal. Yeah? I am setting this goal for my planning group. This goal, which is joint goal, which is all the positions that I am setting here. Yeah? So I am setting this goal for my planning group. Then once I have set this goal for my planning group, I can then call here this plan function. And then once I call this plan function, MoveIt is going to start planning. It's going to start calculating all the inverse kinematics, etc. And it's going to plan the trajectory. Okay? But it's going to plan it. It's going to only plan it. Okay? It's not going to execute it. If I call the plan function, it's going to only calculate the plan. It's not going to execute it. In order to execute it, I have to call this go function. Okay? So the plan function is for planning, and the go function is for executing the trajectory. Okay? And of course, at the end, I have also this stop function in order to stop the motion. All right? So super simple, super simple. We are defining here the planning group, the scene, and the robot in the constructor of our class. Here, we are setting a goal. By the way, you can see that we have this function and this one. This is a correct goal, a valid goal, and this is a goal which is not possible. Yeah, only for reference, it's exactly the same. Yes, but this is a correct plan and this is an error plan. Okay, just for testing purposes. Then, once we define our goal, we call the plan function in order to start the motion planning, and we have also the execute trajectory function, which is going to call this go function in order to execute the plan that I have calculated. Yeah? Makes sense? Then finally, what I have here is this test trajectory function, which is the one that I'm going to call here in my main function. This test trajectory function, what does is to, I call this joint trajectory set plan function, which is this one, which is going to set all these positions for my joints, for the different joints of my group. So I call this function first, you have it here, then I call the plan trajectory function to start the planning, and finally I call the execute trajectory function to execute the plan. Yeah? Make sense? All this explanation that I have just done. Do you see the logic of this script? Why each function and what are the key points of each function? Yeah? Is it clear? Your new construction tool is awesome. Great work, guys. Thank you very much, Ruat. Thank you very much for your kind words. Santosh says yes. Okay, then let's run it. Okay, so let's run it. Then let's come here. We have here MoveIt. So I'm going to run my script. So this script, by the way, this script, you have it already here. Let me show exactly where you have it. Yes, understood. I can see here. Okay, simulation workspace, SRC. Open manipulation. Okay, so here inside open manipulation more first chair, in the open manipulator save MoveIt, which is our MoveIt package, we have the scripts function here. Okay, and here we have this move arm Python script, which basically is the script that we have just reviewed. Okay, it's the same, exactly the same. You can see here, it's basically the script that we have just reviewed. So what I'm going to do now is to run it. Okay, so let me create a new shell. Yeah, so I have in the first shell I have the gazebo simulation. In the second shell I have MoveIt. Remember that I need to have MoveIt started, of course, otherwise the script is not going to work. Then now I'm going to run my script, open manipulator, save MoveIt, and move arm. Okay, then let me have everything ready here to visualize. Okay, so let me run it. Then I should see here how a new motion plan is calculated first. Let's see. Okay, there we go. So a new motion has been calculated and the robot arm is moving there. See? So for instance now, okay, yeah, if this error doesn't matter. Okay, so for instance, let me make a quick question. If I want to send a different goal now, if I want to send a different goal to my robot arm, in which function should I touch here from the script? Where should I touch? In which function here should I touch in case I want to send a different goal? Let's see who answers first to the question. Set plan. Set plan? You mean this one? Join trash set plan? Yeah, it's this one. It's this one. You're right, guys. It's this one. Join trash set plan. So join trash set plan here. So for instance, let me just modify this and set it to. I'm going to set all to 0. Let me change all the values to 0 again, and let's see what happens. So let me run this again, and let's see what happens. So my robot goes back to the 0, 0, 0 position, which is the initial position with the robot arm vertical. Okay? All right, so let's connect to the real robot. What do you say? Let's try all this with the real robot, because now we have seen this basic example here with the simulated robot with Gazebo. We have seen that it works, that we can change the goals that we are setting based on the joint positions. So now let's move to the real robot. Yeah, do you agree? Let's try it. Let's try it. So I'm going to stop everything right now. Let me close this. I'm going to close the simulation. Let me stop MoveIt and stop the simulation, because I'm going to work with the real robot. So let me stop everything. There we go. I have closed the simulation. Let me close Gazebo. All right. So now, in order to connect to the real robot, you have all the steps here. I'm going to show it now very quickly. Here at the end of the notebook, you have the section here. Connect to the real robot in Robox. Okay? So all the steps in order to book a session. Let me show it very quickly. So basically in the construct, okay? So here in the main construct page, in the left bar, in the left menu, at the bottom you have the real robot lab section. Yeah? So if you click here, you can book a session with the real robot lab. Okay? You can, so right now we have here the Turtlebot 3 robot, but for the next week we're going to activate the manipulator arm. Okay? So right now if I try to book, as you can see, I only have the option to book a session for the Turtlebot 3 robot. Okay? But we are going to activate for next week this, the manipulator. Okay? The one that we are using today, so that you are going to be able to book it also. All right? Then once you have booked the session, in your rosject, when the time arrives, of course, you have to select a date and a time, etc. So once your booking time arrives, you are going to see in your rosject an icon like this, with this robot in the red button. Okay? Then in order to connect to the real robot, all you have to do is to turn on here the connection. Let me do it right now. And as you can see, right now I am connecting to the real robot lab. Then you are going to have to wait a few seconds until all the connections are done. So now, as you can see here, this streaming window has just opened, where I'm going to be able to visualize the real robot. Let's see if it loads. It's taking a bit of time here to load. Let me close it and open it again. Okay, so the streaming is not showing for some reason. Let me see if I can, let me quickly check if I can see the topics of the robot, of the real robot. Yeah, I can see the topics, but I cannot see the streaming for some reason. Okay, so it's pretty strange. I am connected to a real robot, as you can see. I can see here the topics, but for some reason the streaming is not working. Okay, let me wait a couple of minutes here to see if my colleagues can check and solve it for me. So meanwhile, let me check here. In the MoveIt GUI, Piyal is asking, in the MoveIt GUI, I selected ARM0 for start state and selected ARM home for goal state. how can I make a loop of it? In the GUI you cannot make a loop. In the GUI, using the GUI, you cannot make a loop. In order to create a loop, you have to do it from a Python script, PL. So actually the GUI is more for testing, really. For testing, you can set goals in a visual way. For instance, like I have shown it at the beginning, by moving the end effector to positions. And it's the GUI, it's very useful for testing, for demonstrations also, for instance. But in case you want to create a loop and things a bit more complex, you have to do them from a Python script. Okay? Then in a Python script, you can create a for loop and create an array of different plans. Okay, let me see. There are some examples indeed. Here, if I'm not wrong, maybe you can see some examples here. Let me see. I believe maybe we have some examples here of creating loops. Yeah, here in these scripts here, you have some examples that you can maybe check here to see how to create loops, etc. Okay, let me try one thing that my colleagues are telling me. I'm going to disconnect from the Real Robot Lab and try it one more time. So let me disconnect and reconnect, and let's see if I can test it here in the Real Robot and this streaming thing gets fixed. Okay, so now I am disconnected. Now I have disconnected, so let me try to connect again. Turn on. All right. Let's hope that now the streaming of the Real Robot is working properly. Let's see, here I have the streaming. And no, it's not opening. No, so for some reason, this is not opening. Let me try to close it again. Is it only with me that they did? Try refreshing, maybe PL. Here, click on the reload button, maybe. This helps. Here, reload button. Okay, let me open it one more time. If it not works, I'm going to close here, unfortunately. Yeah, this is not loading. This is not loading. Okay, so, well, sadly, we have not been able to show the demonstration on the Real Robot. I'm sorry for that. In any case, I want to remember that we are going to open the Real Robot Lab for the Manipulator robot, so that you can try it for free. So I really encourage you to do it. So you have seen now how to do all this in the simulation. You can have a look at the script, at this MoveIt, at the MoveArm script, sorry. You can customize it as you want by changing here the goals to send, testing different goals, creating multiple goals. So here, for instance, as PL was saying, here we are creating one goal, but you can create multiple goals. Let's say I can create here another one which is named joint goal 1. This can be called joint goal 0, for instance. See? And you can create here joint goal 0, and this would be joint goal 1, etc. You can customize and test whatever you want to test, do your modifications to the Python script, whatever you want. So I really encourage you to try it. Very important, first try it in the simulation, as we have seen in the live class, and once it is working in the simulation, just connect to the real robot, turn on the connection, and test it in the real robot, okay? All right, so let me already finish this. Let me switch here my screen. So yeah, sadly we have not been able to see. So the connection with the real robot was there, as you could see. I was able to see the topics of the real robot, but for some reason the streaming, the image of the real robot, I was not receiving it properly in the rosject. Well, things that happen in live demonstrations and in live things like this live class. So yeah, sorry for that. In any case, I hope you have enjoyed this live class, and thank you very much for being here with me. I hope you have learned at least something from this hour, and yeah, I will see you next week with the next live class. And until then, as always, take care and keep pushing your ROS learning. Bye-bye.
What are you doing, Alberto?
I'm training this intern with ROS.
Oof. Did you have the same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises. A fast and easy way to empower your team with ROS. From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day one. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects. Want to become a happy Alberto? Request a demo today.